List Boeing 767 Cpat review, Powerplant. Most aircraft utilize the GE CF6-80 C2 B6F rated at 60,200 pounds of thrust. The pneumatic starter is connected to the N2 through the accessory drive. Pneumatically actuated fan reversers provide reverse thrust. Rolls-Royce engines and some GE-powered aircraft use hydraulic thrust reversers. The fuel control switches have two positions: run for engine start, cut off for engine shutdown. The red light in the switch illuminates if the engine fire is detected. There are amber lights above these switches that show the position of the engine fuel valve and the position of the spar fuel valve. These are checked for proper operation during start, and each should momentarily indicate to show the valve in transit. There's also a light to indicate the reverser isolation valve, which indicates a fault in the thrust reverser system. The thrust reversers are normally positioned by the auto throttles, but can be positioned at any time by the pilot. The thrust reverser lever can be raised when thrust levers are at idle and the aircraft is on the ground. The thrust management computer calculates reference N1 based on existing pressure, altitude, and temperature. The thrust mode selector panel on the right center instrument panel is used to select the proper capability for different thrust modes for each phase of flight. The TOGA switch is used to select takeoff thrust on the ground and go around thrust in flight. Thrust reference modes are usually provided by the FMC. The start and ignition panel has three knobs and two lights. The start switch, left and right, varies the level of ignition operation, and ground for start operation. The positions are GND ground for starter for starting the engines, auto for normal operation, off to turn off the ignition, continuous for continuous ignition, and flight, which provides continuous ignition of both igniters. The ignition selector selects single or both for both engines, typically selected to the side of the flying pilot. Two valve lights illuminate when the start valve is in transit or not in the commanded position. The EEC, which is a full authority digital electronic controller, or FADEC, monitors thrust lever position and sets commanded thrust, provides protection from exceeding maximum thrust limits. They are self-powered when the engine is running. If an EEC fails, the engine shuts down. There are two E switches which are guarded on the left overhead panel. Normal position provides overspeed and overboost protection. When in alternate, only overspeed protection is provided. The engine indications are on the primary upper ICAS, always displayed, and show N1, thrust reference, and EGT. The secondary indications can be selected on the lower ICAS and show N2, fuel flow, oil temperature, oil pressure, oil quantity, and vibration. The standby engine indicator is normally blank and automatically displays if both ICAS instruments fail. It displays useful information, especially during a dual engine failure. It displays N1, EGT, and N2. Power plant fuel. Fuel flow from the tank through the electric fuel pump, through the spar valve in the tank, to the first stage engine pump, to the second stage engine pump, to the fuel oil heat exchanger, through the fuel filter, the fuel control unit, the engine fuel valve, the fuel flow meter, and into the engine. The metering unit works in conjunction with the EEC. The fuel control system schedules fuel flow to meet engine thrust requirements as dictated by thrust lever position and specific engine operating conditions. The EEC controls the metering unit to prevent exceeding engine limits. Bar and engine fuel valves open when the fire switch is in and the fuel control is in run, and they close when the fire switch is out or the fuel control is in cutoff. Fuel valves illuminate momentarily during transit. They're monitored during startup and shutdown to ensure proper operation. If a valve position disagrees with the switch after the transit time, the light remains illuminated and an ICAS message appears. Left and right engine fuel filter ICAS messages indicate that the filter is approaching the bypass condition. Erratic operations or flameouts may occur if the filter is bypassed. The fuel flow is measured after the engine fuel valve. It's displayed on the secondary ICAS. It's provided to FMS to calculate fuel burn in flight. Power plant oil system. The oil pressure, quantity, and temperature are displayed on the secondary ICAS. Oil quantity usually decreases at start and increases after shutdown. Engine-driven oil pump provides pressurized oil, flows through an oil filter. If it's contaminated, the filter will bypass and an ICAS message displays. The oil flow goes from the pump, through the filter, through the main bearings, through the gear accessory drive, through the cooler, and to the reservoir. Oil pressure is measured before it enters the engine. Oil temperature is measured after the scavenge pump before the reservoir. The indications for oil temperature are amber, caution, red, limit. There is no ICAS message for oil temperature. Oil quantity minimum for dispatch is 17 quarts. There is no limit or crew procedure for low quantity in flight. That concludes Boeing 767 power plant review.